Så, men vi kör väl igång helt enkelt, tänker jag. Och så får väl folk trilla in när de trillar in. Ehm, Varmt välkomna till detta webbinar som är ett uppsamlingsheat i Trafikverkets branschprogram Hållbar sjöfart som vi på Lighthouse driver. Och att ett uppsamlingsheat innebär att det är ett gäng projekt som har precis blivit klara eller nästan är klara. Och vi har ett ganska späckat program idag. Vi har 5 korta presentationer på ungefär 15 minuter stycket. Det är 4 förstudier och ett forskningsprojekt. Och däremellan så kommer vi ju också ha en kvarts paus någonstans. Jag tänker så här, har man frågor så kan man skriva det i chatten så kan presentatören svara på det efteråt. Men vi har nog tid för 1 eller 2 frågor efter varje presentation också. Och dagens program ska vi kika lite grann på och det ser ut så här. Och så avslutar vi vid klockan 11 förhoppningsvis. Vi har lite extra tid om det skulle behövas. Så med det sagt så tänker jag att vi kör igång med Desiree från IVL. Som är projektledare på IVL. Har en lång erfarenhet inom biogas. Och du kör din presentation på engelska.
Precis. Ja, och du visar bilden, Andreas.
Yes, du kan få fjärrkontrollen utav mig här.
Yeah. Okay, so I will take this in English. Great to be here. Nice to see you that I can see. My name is Desiree Gran. I'm a project leader at IVL Swedish Environmental Research Institute. And I will present the project that we have run that just been finalized called Voluntary Climate Targets and their impact on the use of LBG in shipping. And as Andreas mentioned, I've worked a long time within the biogas sector, but not that long time within the maritime and shipping sector. So I'm very excited about this and learning about this together with my colleagues who have worked in that sector for a long time. So this project we have done together with Uppsala University, Björn Samuelsson there. And I will, let's see if I can switch the picture. Can't see that I can, maybe here. Did you see the next picture now?
Yep.
Great. So this is the outline of my presentation. First, a short introduction to IVL, then what has our project been about, and then some parts of the project, voluntary and legislated climate goals, mass balance-based models, and impacts on the use of LBG within shipping, and then some final remarks and next step. So first, shortly, what is IVL? Well, IVL, Swedish Environmental Research Institute, we say that we're Sweden's leading organization for applied environmental and sustainability research. We do research and we do consultancy within sustainability. So it's everything from transport to energy to air quality to water quality. It's very broad and a lot of like climate impact calculations and things like that. So we're in Malmö, Göteborg, Stockholm, and Skellefteå. Yes, that's what we do. So we have for a couple of years worked with different projects within LBG to shipping. And the latest project that we had before this was a project looking into practical barriers of LBG use in shipping. And one of the final questions that we found in that work was issues specifically related to mass balance questions. As of August 2025, about 500 Swedish companies have science-based targets. So they have joined science-based targets. So they have voluntary climate goals for their companies. And science-based targets has indicated that emission reductions achieved through mass balance may not be eligible for credit. So this could raise issues for using LBG within shipping, as a lot of biogas is bought on mass balance through, for example, the gas grid in Western Sweden. And the availability of biogas doesn't always match where the need exists. So it might impact supply and pricing since LPG is traded and provided a lot via mass balance. So this was something that we wanted to look into and to understand. And just to show you that this is a very on topic right now, this was during COP30 in Brazil. There came this article of industry leaders are demanding biogas incentives at COP30. And a number of large firms are urging the GHG protocol to recognize renewable gas certificates before planned 2028 revision impacts decarbonization. So our project, we wanted to look into how will mass balance-based mechanisms be handled within the GHG protocol and science-based targets. When we started this project, we would have gotten a notice from them by now how it will be handled, but that has been pushed to the future. So we will get a full understanding of that in 2028 when they will finalize their revision. And we also wanted to understand how will the outcome of this decision affect the demand and the pricing of LPG if mass balance is not allowed. And this has been summarized in a report with recommendations. So if we start at the part of voluntary climate goals, what are these? Well, we have a number of different voluntary climate goals. We have the GHG protocol, we have science-based targets, we have ISO standards. We also have legally mandated climate targets. For example, IMO, Fuel EU Maritime, EU ETS, RED III, and we also have Skatteverket in Sweden, which gives some things we have to follow regarding LPG use. So how come companies are working with voluntary climate goals? Well, reasons for having voluntary climate goals is usually the legislation is not strong enough that you want to move faster than legislation is moving. You want to move ahead. You want to have a competitive edge. You want to be attractive to customers, secure the future, and be a part of a broader sustainability effort. So a lot of companies are working with the science-based targets schemes. So those are the voluntary schemes. And then for using LPG in shipping, you often use mass balance based. You buy off mass balance based agreements. So what are then these mass balance things that I am speaking of? Well, mass balance based tools can be very different. We have systems called insetting, we have systems called offsetting, we have book and claim, we have pooling. We have a lot of different ways of using mass balance based concepts. And this is something that we wanted to clarify in our report. So I won't go into the details here because I don't have time. As you can see, I'm already talking quickly. But you can find an attempt to description of these different mass balance based tools in our report and to kind of understand how they differ from each other. But to give an example from the LPG market, if we assume that this oil barrel in the middle is the gas grid, you have green gas coming in, so you have biogas that is injected into the gas grid. And you also have fossil gas injected into the gas grid. And then you can buy off of certificates. Either you just take the mix that's there, or you want to have green gas, you want to have 100% biogas, or you want to have whatever else fossil gas. So off of certificates, you can make sure that you buy the right molecules that you want to use in your verksamhet, in your organization. So this is the green gas principle. That's how it works along the gas grid in Sweden today. The infrastructure looks the same. It's the same infrastructure for both natural gas and for biogas, but they are in different places. And in the system, it's important with the transparency or with certifications, with third-party certifications, and to ensure that there's an additionality in the system, that we actually achieve a higher volume of green gas when we're bought into certificates. If you compare this to green electricity, for example, we have agreements that we want green electricity in our home, and then we don't always get the green electrons, but we know that they are injected somewhere else in the electricity system. But there's a lot of discussion in this particular, the green electricity, if this actually achieves a higher volume of green electricity in the system. So this has to be secured if this is something that people will want to use. Other than this type of setup, let me just turn off the låsepeka. You can also have a financial setup where one stakeholder is using the green fuel, reduces the emissions, but someone else is buying the emission reduction from the stakeholder. So they aren't actually using green molecules, but they're buying it from someone else. So this could have consequences for the use of LBG in shipping. If we can't use mass balance-based tools, we could see a rapid increase in transport cost per cubic meter, which we have done calculations for in our report. It could lead to a higher price due to increased demand of locally produced LBG, which will take a lot of more infrastructure and take longer time for things like that to get in place. That could also have an effect on slow down the development of new production, since we use a lot of mass balance-based tools right now. But we are thinking that it might have an increase in production of Swedish LBG, since we have to have it locally, we have to have it close by. The biogas producers in Sweden, a lot of them that we've spoken to, don't agree with us on this, but let's see. Reliable third-party certification is key in this to make this fly, to make stakeholders willing to use these mass balance tools. So I'll lift that again. So just some final remarks. As we've seen in working with this, that a dear child has many names, as we say in Swedish, kärt barn har många namn. We have a lot of different names for these mass balance-based tools. They are often mixed up. It's not very clear what is what. So we have tried in this report and in this work to kind of clarify what is book and claim, what is offset, what is inset, to kind of begin to get an understanding. And what we see is also that it's necessary of an increased knowledge on, for example, what will be allowed going forward, and effects, to understand what will be allowed and the effects of what will be allowed. That is necessary for several different stakeholders. As I said, I will say it again, third-party certification is key in order for stakeholders to want to use these different systems. And we also have to keep in mind that the overall goal is a transport system where fossil fuels have been replaced, and that's what we're working towards. So hopefully this is just a bridge in order to get us there. So we find this very interesting, and we're moving forward with working with these questions in different projects. We have one big mass balance project, which is a triple F project, which is mass balance principles in the transport market as a whole. We also have one project, market outlooks for biofuel for shipping in the Nordic market, which is the Lighthouse project. And we were starting up another Lighthouse project now after Christmas. The shipping sector's LBG needs domestic solutions, looking more into detail of the logistics that's necessary for different solutions. So I will just, sorry I've spoken so quickly. Hopefully I got most of it in place, but I just want to say thank you to our reference group, and that have been very on their feet and interested and come with a lot of insights and thoughts in this. So that has been a lot of fun, again, to work with these stakeholders. So thank you very much. And if you have any questions or confused about anything, or you missed this or this is wrong, feel free to contact us. It's been me together with my colleague Elin Malmgren and Björn Samuelsson at Uppsala University, who has done most of this work, but we will also had Linda Styre and Anders Hjort at IVL working in this as well. So that was it for me. Thank you very much.
Stort tack för det, Desiree. Jag har en fråga. Hur ser biogasproduktionen för maritimt bruk ut i Sverige idag och vad tror du om framtiden för den? Blir den större?
LBG, ja, LBG är det ju som de behöver, alltså den förvätskade biogasen. Och det intresset är jättestort. Om man tittar på de stora anläggningarna som byggs idag så byggs de runt 100-120 GWh kapacitet, vilket är stort i biogas Sverige. Och det är för att man vill göra LBG-produktion. Det är inte bara till sjöfarten utan det är också för att det då finns en bättre ekonomisk möjlighet att exportera den biogasen till andra länder när den är i förvätskad form. Men de sjöfartsaktörerna som vi nu har pratat med i några år, de är intresserade på riktigt och vill detta. Sen handlar det väldigt mycket om prissättningen och vilken betalningsmöjlighet de har och vilket pris biogasproducenterna behöver sätta. Så jag skulle säga att den kapaciteten ökar och att just nu är ju biogasanvändningen, den har varit inom personbilar och bussar, nu har den rört sig mer mot tung trafik, industri börjar få upp ögonen för den och ha intresse och sjöfarten också. Så biogasen är under förflyttning och kan liksom spela en roll som ett bränsle i många av de här hard to abate sektorerna.
Tack för det. Är det någon som har en fråga till Desirée? Nej. Jag tror inte det, jag ser inte alla för jag sitter på en liten skärm. Ja, tack Desirée. Och då hoppar vi vidare till Hanna Varvne från RISE som ska prata om Social Relations Influence over Choices of Alternative Maritime Fuels. Hanna är disputerad forskare på den maritima avdelningen på RISE. Och nu ska jag försöka ge dig en fjärrkontroll också. Så du kan blippa bland bilderna själv om du vill det. Så, kör hårt Hanna.
Thank you. When I heard you say the title, I realized that maybe I should have practiced saying the title a few times because it's quite a twist in the mouth. But yes, so me and Selma at Chalmers, we have investigated the social relations influence over choices of alternative maritime fuels. So what is important to keep in mind with this was that I'm an organizational scholar. So I wanted to explore the decision processes among ship owners from a quite different perspective. And I'm very thankful that Selma also wanted to join in on this project and bring in the maybe more traditional and rational views from LCA perspectives and all the other perspectives that she comes with. So it's been very fruitful for both of us, and I think that both of us have learned a lot from each other. But in this project specifically, or pre-study, the aim was to explore how theories from organizational studies, and particularly those addressing bounded rationality, can be applied to the decision process of alternative fuels from ship owners. And this also include a cognitive view on the decision process, so very much into how decision actually happens as a process rather than how we expect them to happen based on rational choice. So I thought that I would just jump straight into the project and what we did. So I would say that we used a quite iterative process with our collaborative partners. So first off, as you always do when you do a study, we did some literature browsing and drafting of first mind map to think of what we wanted to explore in terms of these social relations. And then we discussed this with the ship owners. And of course, we came back a lot wiser. So their input brought us back to the desk completely, and we had to redo the entire literature review, refine and re-refining what we had found, and also change the scope of the project somewhat. And then we did a second round of interviews with the collaborative partners, and we got even wiser, and we re-refined it again. And at this point, we started to feel like we had, we had reached a point where we knew pretty well the insights from the companies who were already part of the project. So then we actually reached out to a few other ship owners and did some complementary interviews and got even further insights. And then we also did a round of reviews where we sent a first draft of the report to ensure that everyone we had interviewed actually agreed with our interpretation of what they had said. And this was, of course, to ensure that that we haven't done any misunderstandings, but also to make sure that everyone feels confident with the context in which this is being reported. And here I would also like to already mention that we have had a very wide agreement on or discussion on anonymity in regards to this, because this showed out to be a very sensitive topic, but it was also very mixed among the different ship owners that we interviewed. For some of the ship owners, they were perfectly fine with openly disclosing name and affiliation and everything, but for some others, they were more reluctant. So I think this really shows how complex it is when you try to really dig deep into these kind of decision processes. For some organizations, this is very sensitive, and for others, not as much. But I'm really grateful, independent on if you wanted to stay anonymous or if you were open with your name. I think everyone has really contributed it and been very open and really showed that we have a lot to learn about how these social influences actually take place in the decision process. So we did 12 interviews, and then we used NVivo to to find the themes of what was discussed. And I think a few of these themes, they are kind of given based on the aim of the study and what we actually try to explore. The fact that we have decision factors as one of the huge group, or energy sources, I mean, those are kind of given due to the scope of the study. But maybe a bit less taken for granted was that ship specific is actually quite important in this as well. But also, of course, all kind of requirements, regulatory or financial or whatsoever. And also how you collect information and what kind of timeframes that you are actually working with these kind of decision processes. So what we did was to kind of break this down. We used a scholar named James March and his theories of decision processes. And we interpreted those kind of freely, but we found, for one, that networks and action nets in decisions are important, that the temporal order of decision processes is very important. And in terms of temporal order, we are discussing it both in terms of how long these decision processes are. So that means some of the ship owners we have interviewed, they're talking about these processes being 30 years old or long, maybe 20 years long. So you have to keep in mind that these decisions are not something that happen at one very specific point. These are a multitude of decisions happening in connection to each other. But it's also important to keep in mind that for the temporal order, these decisions don't take place in a vacuum where you don't have any other organizational actions taking place. So at the same time as you're making decisions of retrofitting or building a new ship with an alternative fuels, you're also taking care of your daily business. And that can be yard visits, it can be all these kind of things. So there are a number of temporal cycles that take place at the same time. But we also found and explored how decision support tools act as symbols and constructions of meanings. And this is, for example, LCAs and so forth. And we will look into a figure of those next. Yeah, here it comes. So what we found is that there are different groups of these kind of decision support tools, and they can be procedural, analytical, or aggregated. And we found a few different of these in the interviews. One that stood out as procedural was backcasting, where you're using this method to kind of guide your decision path forward. But another one is multi-criteria decision analysis, where you try to take in as many criteria as possible before making your choice. We also identified some analytical tools, for example, life cycle assessment. But when it came to life cycle assessment, most of the ship owners said that this was something that they didn't use primarily as an information source, but the life cycle assessment is often very influential in the regulatory frameworks that guide their decision. So they might not use the the life cycle assessment directly, but the life cycle assessment has such huge influence on the regulation that comes next, that it still becomes used, but in somehow like in a second step. And we also saw that the ones that are combining environmental and economic focus, those kind of factors are very important as well. And we also investigated some things about the use of indicators, which we are calling aggregated decision support tools. And in general, we can say that the decision support tools are used both to kind of create a basis for making a decision, but they're also used as a symbolic way of creating meaning of the decision that you are taking. So they have a double function. And another thing that we found, it is that in these networks where you're creating your decisions of alternative fuels, these networks can be based on business organizations, your suppliers, your customers, and so forth. And they can also include gathering information from news and media. But something that is coming up now is that you see a need to actually secure your future fuel. And this is something that is sometimes done quite reluctantly among the ship owners. So you might feel the need to become your own fuel supplier, but you might not necessarily feel like that is the way that you want your business to go, but you might not have a choice. And we also had some insights on the design for future studies, which I think it's important to bring with us today. And as I said already in the beginning, this showed out to be a very sensitive topic, and to gain access to these kind of organizational spaces where these decisions take place, it does not really work with a 1-year pre-study. It's not enough time to build the trust necessary. It's not enough resources to spend the time that you need to be there in place. So for future studies where you want to discuss these social relations or decision processes among alternative fuels, we believe that you need to have a very strong connection to the organization where you investigate this. So we are suggesting more or less that it should be close to an industrial PhD or a very elaborate choice from the participating organization to share this kind of knowledge. And that one might need to be a bit reluctant on how to design these studies in the future, because it is, it is a lot of things that are tangling into being some sort of trade knowledge and therefore very sensitive out of commercial reasons. So just to wrap up, I wanted to share a final figure, which actually is not included in our report, but it summarizes it quite well, and especially this with how to think about designing the study. Because what we believe is that if you see here in the picture, now I should also have this pointer. If I can get it started. Yeah, so here, what is known and what is now, those kind of decisions, those are very commercially sensitive. So this is most likely very hard to get access as a researcher, and might be quite hard to study. But when you're looking here further into the future with more uncertainties, these kind of questions or alternative fuels are likely more easy to investigate, because they are not as sensitive today, because they are not on the market. And there are also projects where the ship owners often already have collaborations with researchers in other capacities, such as technical feasibility and so forth. So it's more likely that technologies that are more novel are more easy to investigate, also based on a social and decision process level, than the more mature technologies, which could maybe be like LNG or something like that. And I think I'm already out of time, so maybe I should wrap up now. And
du är precis på tiden. Spot on.
Yeah. Yes. So that was what we had time for. Thank you.
Stort tack för det, Hanna. Det är hyfsat stora beslut att man ska bygga om eller bygga nytt för ett alternativt bränsle för en redare. När ni har pratat med redarna, är det liksom, är det marknaden, nya regler eller tekniken som är det mest drivande, som påverkar mest? Kan man säga någonting om det?
Jag skulle nog säga att det blir en kombination av dem. För det är ju, vad ska man säga, ja, men det är den här som vi pratar om med de ekonomiska bedömningarna. Du vill ha så mycket CO2-minskningar du kan för så lite pengar som möjligt. Det är ju också viktigt att du säkerställer att du uppfyller nuvarande och kommande regelkrav.
Saknar rederierna något beslutsstöds, alltså kan vi hjälpa dem på något sätt som ni har kommit fram till? Eller när ni har diskuterat med dem?
Men jag tror verkligen att vi hamnar här i det här svåra gränslandet där det finns ju otroligt mycket rationellt beslutsstöd idag. Men det rationella beslutsstödet idag, det hamnar ofta i forskningsrapporter och blir kanske väldigt abstrakt. Och jag tror fortfarande, alltså även med den här förstudien så tror jag inte vi har kommit tillräckligt långt för att kunna säga exakt hur deras beslutsprocesser ser ut för att heller kunna ge en bra rekommendation i hur ett sådant stöd skulle se ut, utan det faller ju hela tiden tillbaka i att det här hamnar i gränslandet mellan vad som är kommersiellt känsligt, vilket jag tycker vi ska ha full respekt för. Utan tvekan, jag menar, de här rederierna har verkligen öppnat upp och bidragit jättemycket trots det. Men det gör det också väldigt svårt för hela området hur den kognitiva beslutsprocessen går till. Är väldigt svårbeforskat och därför också väldigt underbeforskat skulle jag säga. Jag skulle också tro att vi i sjöfarten är väldigt ovana vid den här typen av studier. Vilket kanske också gör att det är lättare att samarbeta kring att utveckla en teknik men svårare att samarbeta kring att utveckla ett beslutsstödssystem som är processuellt och inte rationellt.
Tack för det. Någon annan som har en fråga? Hemskt vad ni var blyga idag. Okej, tack så hemskt mycket för det, Hanna. Då har vi en presentation innan vi tar en kvarts paus och det är Lena Granhag från Chalmers. Lena kan allting om invasiva arter. Docent, transport, energi och miljö och kommer ifrån Chalmers. Och nu ska vi se, Lena, så du ska få en kontroll av mig här också. Så Lena, nu ska du kunna trycka fram. Längst ner till vänster där har du de där.
Ja, tack så mycket Andreas. Invasiva arter, och de gömmer sig ju i påväxten som är biofouling, och I will switch to English and take this. So I'm Lena Granhag, based at Chalmers, and now we will zoom in at the ship hull. First I would like to say that we are really happy to get this opportunity through this pre-study to investigate the status within this field that actually is very close to me since I'm trained in a very narrow field called biohydrodynamics. Within this area now, I'm a little bit afraid that if this is simplified too much, you will actually have inaccurate results. So I will give you some sort of a mini lecture today, and by that I hope that I can explain the importance of keeping track and really give good enough details on what you do in your testing. So the aim of this pre-study was to describe dynamic testing and focus on how dynamic conditions impact the results in testing of antifouling paints. And I bring two challenges up front. First, saying that there are several disciplines, meaning several scientific fields needed for the accurate interpretation of the results you get in those studies. And then another thing is then when you use biofouling roughness in the modeling to predict the impact on ship performance, that is a challenge due to that the biofouling is alive, it's living animals and plants. And when they are exposed to water flow, they can deform and even get removed. So it's not a simple constant to work with. Okay, and now I would say that the status in this area is that we work towards the collaboration between industry and academia. As the paint producers, they have for a long time been doing dynamic testing. However, from the angle or with a perspective to look at the durability of the paint and the how resistant the paint is over time. Although this is not openly available results, we at least can have this discussion on a conceptual level and what not need to be included. Somewhat closer is the aligning of methods within the research field to achieve sound interpretation and to, above all, be able to compare our results. And I would say that there is a consensus between the industry, the paint producers, and in the research too, that there is a need for standardization in the dynamic testing. What we did, our method was that we did a literature overview. So we went through the most recent literature and found out that literature on dynamic testing of antifouling coatings are quite scarce, about 30 publications. And while the static testing, as shown to the left, is really widespread and with a lot of studies where you submerge panels in the port or harbor and you let them stay there for like 6 months. While to the right then you have the dynamic testing when you expose your panels painted with different antifouling paints in a flow regime of some sort. And here this example is of a rotor device for testing efficacy of antifouling coatings that has been used in the Mediterranean. And when we compiled the recent literature, we looked at what biofouling type that was used. We looked at the dynamic setup used and summarized the findings that were due to the dynamic condition. And the results, we could see that under dynamic conditions, the impact of the slime layer, which is the very first thin layer that consists of microorganisms like bacteria, microalgae like diatoms, and larvae of the organisms that then will grow into the mussels and barnacles that we can see. They have the larval stages that will also belong to this slime layer. And in addition, this slime contains a matrix of extrapolymeric substances, and this is very important for the attachment. And we could see that most impact was seen on the foul release coatings. But that doesn't mean that they did better or worse. It just means that they were more impacted. They could, for example, have more or less different organisms attached, or that the attachment could be stronger, or they could be more strongly attached within this slime layer. And now I'm starting to give you some more information on the biofouling on the surface. And the smallest organisms that's attached are about 1 micron. And then we have the algal spores that are 10 times larger, but still very small. And everything is then within these extra polymeric substances, meaning that they cannot be viewed as single organisms, but rather this layer where they all be components. And you can see to the right a larvae of something that will later grow into barnacle, and that then the size is getting quite much larger. And if we look at what happens around the ship, the ship moving through the water will create a flow. And in the bow of the ship, in the fore of the ship, you will have, for just a few meters, a so-called laminar flow, and then later it will turn into a turbulent flow. And just next to, I can use this, just next to, let's see, next to the surface, you will have something that is called a boundary layer. And this layer is where the water flow will be affected by the ship hull, or that it's close to a surface. So zooming in, the laminar flow will be water velocities that decrease when you get closer and closer to the ship hull. And then later, when you have a turbulent flow, the water velocities will also decrease the closer you get to the ship hull, but there will also be a lot of those swirls or eddies, and it will not be that, the velocities will not be that parallel as they are in here. And the turbulent flow is the most common out in the sea and around the ship. But every time you get really, really close to the surface, you will have something that looks like this laminar flow. And at the very, very surface, there is something that is called a no-slip conditions, where you have actually no velocities at all. And I want to give you this because for each velocity arrow, you have a corresponding force, which is what the barnacle will experience. And if you do a measurement on land, you use this instrument and you try to push the barnacle away, and you see the force needed to push it off the plate. And it will be the same thing that the barnacle experiences on the ship. You that are very trained in physics, you will see that this here I have expressed the force in Pascal, which actually is a pressure, but it is the same as the force over a certain surface. Okay, and it is very close layer, the layer very close to the ship, just some micrometers to the surface. I said there will be zero velocity. And 1 micrometer is very small. A diameter of your hair is about 100 micrometers. So we are in really, really small scales here. And if we zoom in, the microalgae that I talked about that are in this EPS slime layer, they are about 10 micrometers, meaning that they can hide in this layer very, very close to the surface where there are almost no velocities. So they will not be exposed to the force, and they can still be in this layer and use their glue and adhesive and attach. Where you have the larger organisms like the barnacle larvae, they can also go in here, but of course they will experience some higher velocities. Yes, and I showed you 2 examples. It said that it's about 4,000 different organisms that live as attached life forms, meaning that they are only moving when they are in the larval phase. And then they stay attached for 2 to 5 years, and they need a strong adhesive. So the glue, it can look different. The mussels, for example, they have those threads of glue, and the barnacle, it's actually a barnacle up here. It instead adhere a large part of the animal. And we want to see how this, what happens in the dynamic conditions. And it's not difficult to create dynamic conditions. There is actually a lot of different devices around. For example, flow channels or flow tunnels. You can have the rotating cylinders, sometimes called drums, or you can have rotating discs, or you can actually expose your biofouling on a boat. And it has been two reviews recently explaining the details of those and advantages and disadvantages. So we instead went for this the most recent literature, as I said. And one thing that I pointed out was the difficulty of using this biofouling roughness when you want to translate it into ship conditions. And to achieve the most accurate results in this type of work, you need to use the towing tanks. And this is the large-scale testing facilities that is used when trying out different boat models to see the resistance before they are built, and they are around in some parts of the world, and they use this already standardized measurements. However, it's very costly and time-consuming to perform this type of work. But to have a really, really accurate results, you need this type of facility. And sum up, for hydrodynamics, you need to have control of your flow and the forces that act on the surface, because otherwise you don't explain well enough what you actually have, how much forces you have placed on the biofouling. And you should also remember that the biofouling, they are really small, they are many different sorts, and they have this different types of different strengths of their adhesive. And the types of biofouling that you work with, you also need to know to get those characteristics. So what we did was that we compared then the static immersion tests with the dynamic immersion tests, and we looked at the main differences. And I will say out that the purpose you will use it for is the most important, but then also that the big thing is that static immersion tests, they are quite easy to standardize, while the dynamic immersion tests are more difficult to standardize. So I would say that there is where we are right now to work on how we could standardize those tests. So you need to select your dynamic method dependent on the purpose of your testing. And you need to have the awareness of that several factors will impact the results. And to solve this, we suggest that you have a multidisciplinary approach, combining biology, hydrodynamics, surface chemistry, and physics to be able to interpret the results accurately, and that, again, work towards a standardized approach. Yes, thank you.
Toppen, tack för det Lena. Ta fram en standard, hur gör man det praktiskt? Vilka organisationer måste vara med?
Ja, alltså det finns dessutom, jag tror inte mer, redan några ASM-standarder för hur man gör test. Men jag tror att hur man gör det praktiskt, det finns ju ISO-standarder, och det bästa vore väl att det blir någonting som helst att det kommer via IMO, och man får liksom det så vidsträckt som möjligt.
Just det. Någon som vågar sig på en fråga?
Det finns en fråga i chatten. Ja.
Bra. Då kan du dra den här.
Ska vi se.
Ja, precis, men då måste jag kanske översätta den till svenska nu. För jag gjorde den på engelska. Nej, men jag var lite nyfiken för vi har ett forskningsprojekt där vi testar foul release coatings. Så därför var jag nyfiken på om dynamiska tester skulle ha olika effekt beroende på om du testar en traditionell färg jämfört med foul release.
Jo, men det var ju det som vi tyckte att vi såg. Nu var det ju inte så väldigt många studier och de var ju gjorda med olika utrustningar och det är kanske inte egentligen jämförbara direkt, men att det vad som händer det är både om de växer upp i dynamiska förhållanden, då kan de liksom göra den här slimet tätare och att det sitter fast bättre. De anpassar sig efter det. De bygger upp slimet med olika komponenter efter hur förhållandet är. Så man kan både se den biten och att sammansättningen av vad du har för biofouling kan ändras också, vilka grupper och typer du har. Men det är ju liksom bara delar i det som man till slut läser av. När du gör din avläsning så ser du ju kanske en täckningsgrad och av vad. Men vad jag är nu menar är att man behöver också lägga till mer data innan hur man gjorde det egentligen. För att ja, i alla fall för att kunna
Jag är lite
jämföra.
nyfiken för den färgen vi testar, där behöver du hålla en viss hastighet för att foulingen ska släppa liksom, och det har ju varit svårt att testa det.
Precis. Ja, men de är ju ofta, eller i alla fall tidigare varianter av fallrisfärger gjorda för att man måste komma upp i en viss hastighet för att den mekanismen ska fungera, att de liksom är glatta och att fallringen släpper. Så där beror det definitivt på varför, hur hög hastighet man får upp.
Tack för det. Då är vi framme vid kaffepausen och jag tänker vi håller knappt en kvart, så 9:05 ses vi här igen helt enkelt. Så hämta kaffe eller någon annan förfriskning så ses vi om en stund. Ja, nu kan du ta tillbaka den.
Ja, perfekt. Då ska vi se här. Här nu. Ja, nu. Nu ska vi se här då, om det funkar. Ja, okej, där. Perfekt, nu funkar det. Ja.
Tjusigt. Teknikens under.
Yes, även med nya datorer.
Ja, men det är ju, efter alla år med sådana här online-möten så är det fortfarande lite sådär med vissa grejer. Som
Jag tänkte bara se, jag syns bra i bild va? Tänkte
ja,
jag försökte nämligen få fram här nu så att jag vet inte varför det är. Ja, hushållsnätet ser bra ut i bild för att det är, så att det inte ser naveln på mig.
Nej då, det är perfekt.
Jag ser inte i högerspalten nämligen här.
Nej. Förstår.
Mm. Nej, nej, där var det. Ja. Men vad 17.
Så, då hoppas jag de flesta har kommit tillbaka, eller i alla fall är med och lyssnar. Dags för Henrik Ringsberg från Chalmers, programansvarig för masterprogrammet Maritime Management, bland annat ska jag väl säga. Henrik ska prata lite grann om hållbara infrastrukturer i svenska skärgårdshamnar, eller hiss. Så kör på Henrik.
Thank you, Andreas. As mentioned, I'm Henrik Ringsberg. I'm a researcher, but also here at Chalmers. And the project which I'm going to present today is sustainable development of archipelagic port infrastructure structures. And I will be using the following agenda, starting with actually a short introduction. Then I will talk more about the HIS project, how we collect data, and finally ending this presentation will give you some results, but also, of course, conclusions. As you already know, archipelagic port has been increasingly important due to provision of energy, information exchange, and transport, but also increased important due to the development of regions and municipalities. In addition to this, we have received, or the industry have received, increased requirements regarding development, about sustainability, but also linked to the demand of multimodal, intermodal transport in the nodes of the transport systems. So the HIS projects actually focus on regulatory policies and strategies in development of archipelagic ports at public and local authorities, but also on challenges at public authorities, which they actually experience in their planning, societal planning of archipelagic ports. We use the following two research questions to explore policies and strategies, and also challenges. Which challenges exist in planning of sustainable development of archipelagic ports, and how do actually regional and local authorities comply with these regulatory requirements on sustainable development of such ports? We started actually with a huge structured literature review on the subject, which was later followed up with a case study of regions and local authorities, but also port authorities. The structured literature review looked into scholarly papers, of course, on the subject, but also on published strategies and regulations found at Eurolex, EMO, and of course at the Swedish Parliament. The case study was included on both regional level but also local level. So here we managed to get Region Stockholm, Region Västra Götaland, and Region Värmland on board. And on the local level, we managed to get data out from Öckerö municipalities, Tjörn, Grums, and Kristinehamn municipality. In addition to this, we also reached out to, in total, 8 different port authorities. Of course, in the stated regions and municipalities. In order to collect data, we used mixed focus groups interviews, as mentioned, with 8 port authorities lasting for between 30 and 45 minutes, and of 6 local, regional and authorities lasting between 1.5 hours. These mixed focus groups interviews use both open-ended questions, focus on regulatory guidelines and special knowledge about regulatory guidelines, in total 9 questions, but also 17 closed-ended questions focusing on challenges in sustainable development of archipelagic port infrastructure, in total 17. The first finding, which we actually could see from our study, is that the regulatory framework and that must be considered when it comes to development of an archipelagic port infrastructure actually includes three different levels. At first, we have the international level, which is pretty much non-statutory. It is here where we find UN nations sustainable goals, for example, but also the requirements put out by MARPOL and EMO. Then we have the second level. It is here, which is pretty much statutory. It is here where we find all the European regulations and directives. And then on the third national level, in this case, of course, it's just Sweden, which includes a mix between statutory and non-statutory requirements. These regulations also, especially on the third level, can actually comprise both regulation on fiscal planning, but also strategic planning. Fiscal planning regulations are normally considered at regional and local authorities in planning of port infrastructure. When it comes to stakeholders' regulatory compliance, and especially their knowledge about these addressed regulations, we found that all level stakeholders lack in some kind of way knowledge about regulation, especially on the first, second international level. The regional level stakeholders possess knowledge on regulation on the second and third level, and of course the local level authorities, they possess knowledge on the third level, which actually includes, of course, fiscal planning. We also found that many of the master's plan are not updated and thus also need or must be updated, since they have not been updated for like 20-25 years. And we also found that there is such a lack between statutory acts on the third national level and implementation of regional policies. When it comes to challenges, we found for first that challenges regarding collaboration, communication, and governance includes a lack of collaboration, but also lack of structured and lack of a business forum for collaboration between the different stakeholders. This communication is also very informal and driven by personal networks or by industry networks. And finally, which is probably much the most important finding, is that this communication is and collaboration is based on unclear mandates, a lack of operational capability and competence, which of course leads to hesitations when it comes to investments. The second finding which we found in our study includes funding. Insecurity when it comes to long-term investment, absence of a clear and stable demand due to renewable fuel, which has also been addressed in media, a competition from fossil-based alternatives, lack of a joint funding, and which is also very important, lack of funding when it comes to collaboration between regions. There are money today for local municipalities to collaborate, but not between region and region. Finally, we have the physical and geographical challenges. such as the challenge of remote locations, cause an archipelagic port infrastructure is located in a might be related in a remote area. But we also have physical challenges, such as limitation in physical space, depth limitations, outdated infrastructure, and lack of standards when it comes to technical requirement specifications. To summarize our study, show that there is a limited knowledge about statutory regulatory guidelines when it comes to development of archipelagic port infrastructures. And we also found some challenges that should be considered for in development of archipelagic port infrastructure. And I will actually stop here, saying thank you for and ask if there are any questions.
Tack för
Thanks
det.
for listening.
Tack Henrik. Om ni får önska, vad gör man åt detta problemet?
English, Swedish.
You can make it in whatever language you want. But so to address this problem, what do you think is the best way?
I think that the best way would be at first to provide money for cooperation between regions. Because today, you know, the region of Västra Götaland might actually develop a port infrastructure to comply with the requirement of perhaps setting up an electric node, right? Without any knowledge from other nearby regions, and you can actually jointly use these energy nodes, right?
Yeah, sure.
So at first, more money into that aspect, and then of course we also link to funding. This must be we must look into a long-term funding of energy nodes. Of course, what we also found was that at one local municipality, they have actually established one energy node based on received research money. But then they just recently decided to take this node away because, you know, they found out that nobody was using it any longer.
And I mean, a twist of this is, of course, that all these ports that you have been discussing with is owned by the municipality. Then we have not many, but a few that are private owned. And I was engaged in one of those private ports a couple of years ago. And when we went to the bank and said we want to borrow money, the bank just looked at us and said, what do we need a port as a security for? That's no good at all. So that door was actually closed. Right, any other questions?
Ja, Rickard Engström här. Jag kämpar lite med att se vart den lilla handen är för att sträcka upp den, men jag misslyckades, så jag bara tar ordet helt enkelt. Jag tror att Andreas är inne på ett viktigt perspektiv här, och det är ju liksom ägandestrukturen. Men jätteintressant Henrik, och kopplat till dessa utmaningar du målar upp, de är ju ganska omfattande, och jag funderar på liksom om man tittar ur ett internationellt perspektiv, har du kunnat göra det, eller har du någon känsla för det, hur det liksom ser ut? Jag förstår att det inte är del här egentligen, men om man liksom tittar utanför Sveriges gränser, sticker vi ut på något sätt i detta? Jag tänker såväl avseende samverkan, kommunikation, governance, men också funding-perspektivet. Är vi sämre eller bättre? Har du sett något sånt?
Jättebra fråga. Jag har tittat lite grann på våra grannländer, och naturligtvis det här när vi gjorde den här, det var därför också gjorde den här litteratursökningen, för vi ville titta just utifrån vad finns det publicerat kring detta utifrån ett internationellt plan. Va? För att då kanske man kan hitta något papper som just tar upp det här. Men sen så är det så att det hittar jag inte så mycket förutom en del studier som är gjorda i Norge som framförallt fokuserar på elektrifiering utav färger där. Och så att i Norge där ligger man i framkant när det gäller det. Man har också bland annat något som heter elladdningskartan där man kan se var man kan landa sin färja då ut med den norska kusten. Och det innebär ju också att man utifrån perspektivet att man faktiskt kan samutnyttja de här energinoderna. I det här fallet är det bara el. Men jag tror att man behöver titta på utifrån ett mycket bredare energiperspektiv. Vad finns det vätgasnoder som man kan då samanvända? Likaväl som man kan naturligtvis få upp en karta där man kan ladda sin elbåt eller vad finns det biogas va? Då. För att det är inte säkert
Ja,
att...
tack. Spännande. Jag såg faktiskt just på tal om en sån här karta som du är inne på, det såg jag precis att Skogforsk hade väl något forskningsprojekt, jag vet inte om det var via Tripp eller efter, där de har tagit fram en sån karta för lastbilar och det skulle väl förstås kunna behövas även inom sjöfarten i alla fall på sikt. Tack.
Ja, tack.
Det har faktiskt funnits projekt för att ta fram den här typen av karta för just sjöfart också med ett verktyg för att kunna beräkna hur mycket energi man behöver också för att ta sig mellan de olika punkterna om man vill bygga om så att säga sin egen båt. Men Elinor Forsström på RISE har haft ett sådant projekt så där finns en webbaserad lösning, men den är inte up and running för detta och den är inte heltäckande än.
Får jag bara säga, ha ett avslutande ord. Den här idén kom alltså från Johanna Rantzi som sitter ju i riksdagen för sjöfartsfrågor.
Ja, trevligt.
Och jag rapporterade av den här resultaten för henne här för 2 veckor sedan. För att hon sitter alltså och skriver just på en motion omkring detta.
Okej. Det kan vara bra att veta för jag träffar henne ikväll tillsammans med 20 andra politiker och ska prata om vår forsknings- och innovationsagenda som branschen har tagit fram. Så, ja, tack för det.
Tack.
All right, Jane, it's your next, and Jane has a PhD in maritime affairs and specializing in maritime environmental management from WMU, World Maritime University in Malmö. And you work as a postdoc right now at Chalmers, if I understand it right. And I think that you have got the control of your presentation. And this is a research project, so you will have a little bit more time to present this, about 20 minutes, we said. And the theme is cost and environmental benefits of alternative scenarios for the management of ship-generated grey water from cradle to grave. That's the longest title today, but please go ahead, Jane. You can change the slides down to the left. You have an arrow that's backwards and a little bit more to the right is forward. There you go. And then I don't know if you're unmuted or because we can't hear you. We still can't hear you if you're trying to say something, so you need to push the microphone icon. If you let me just now, I will take the control again, Jean, and I'll see if I can unmute you.
Can you hear me?
Yeah, good.
Okay. Thank you very much. Okay, my name is Janet, or call me Jane. I've already been introduced, so I don't want to take your time. We're going to make a presentation on the cost-benefit analysis of alternative ship-generated greywater management scenarios from cradle to grave. Okay, so we will talk about the background, the rationale of the study and the aim, and why we choose Trelleborg as our case study. And the methodology we use will present some results, and how these results inform relevant regulations and some industry and policy implications of this study. And then we will not stop. We will have to talk about the limitation of the study, because we had some, as well as the way forward. So greywater comprises water from the showers, the sink, the galleys, and laundries on board ships. And they are divided into three major categories, which are the accommodation, the galley, and the laundry greywater streams. And the streams contain contaminants, which have been analyzed in our prior research, and in the literature as well. But despite these substantial loads of contaminants in greywater is still not regulated under MAPOL Annex 4. As a result, the management strategies are fragmented. Each shipholder would manage greywater in its own way. Some discharge into the sea untreated, some mix with black water, which is sewage, and treat before discharge. Others mix with food waste before discharge. Another type of management is the discharge to port reception facilities, and then it is treated in municipal wastewater treatment plant before discharge. And as ship traffic grows within the Baltic Sea, it is very important. I mean, the lack of an international regulation makes it important to try to look at the best management strategy for greywater on board ships. So this study provides this kind of research and data for us to look at several scenarios and to know or to determine which one could be adopted and used within the Baltic Sea. So the aim of the research would be to study the characteristics of greywater on board ships, specifically RoPax ships, and then to model scenarios using Trelleborg as a case study. Then we went further to use these characteristics of greywater to derive shadow prices. I don't know who's touching the screen. Okay, to derive shadow prices for greywater contaminants. Then we also looked, calculated the social and stakeholder costs of greywater management and the environmental benefit, which was used to obtain the net societal benefit using the methodology cost-benefit analysis. And at the end, we provide some recommendations. So we use the greywater management treatment system in Trelleborg, because Trelleborg is an important port within the Skåne, within Sweden in general. It is one of the two ports that possess a port wastewater treatment plant. And it a major hub for RoPax ships within the region. The greywater generation within Trelleborg, annual generation is about 40,000 cubic meter per year. So when greywater is generated from the sheet, it is discharged and it is received by pod reception facilities. This is an example that there are examples of pod reception facilities found at the Trelleborg port. And with this one, we have it receives both greywater and black water, and it also delivers fresh water to the ships. Then from the reception facilities, these reception facilities have underground pipes that lead the wastewater to this area, which is the port wastewater treatment plant. And you have a very big basin that receives the water. Reactions happen there. We don't go into the details. And inside the treatment plant, this is a whole lot of processes and pipes, interconnected pipes that treat the wastewater. And it is important to state here that at the Trelleborg port, this treatment plant actually mix black and gray water. It doesn't treat only gray water, but it treats black and gray water. But for our modeling, we are looking at, we are modeling only gray water, not black water. Then it leaves the port wastewater treatment plant and it goes to the Trelleborg municipal wastewater treatment plants, where it is finally treated and discharged into the sea. So this is the system that exists in the at Trelleborg. But for the purpose of this study, we actually modeled 5 major scenarios, and the fifth scenarios is also divided into 5 major scenarios, 5 scenarios. So we have 5 non-reuse scenarios and 5 reuse scenarios. So for the first scenario, gray water is discharged directly into the sea after treatment, after the generation. The second one, it is treated in advanced wastewater treatment plant before discharge. In the third one, it is delivered to port reception facilities and treated at the municipal wastewater treatment plant before discharge. So this scenario 3 is the exact scenario that takes place at Trelleborg. It takes place at many ports within the Baltic Sea. But the fourth scenario is a scenario that takes place at Trelleborg, where gray water is discharged to port reception facilities, further to port wastewater treatment plant, where it is pre-treated and then discharged to the municipal wastewater treatment plant before it is treated and discharged into the sea. For the fifth scenario, we try to model reuse of gray water. I mean, we want to think about what if we reuse gray water after treatment at the port for various non-potable purposes. And so gray water is discharged to port reception facilities, is treated at the port, and in scenario 5A, it is discharged directly into the sea after treatment. In 5B, B1, the gray water is 100% reused at the port. It means that all the gray water that is treated is reused. And B2, for B2, 75% is reused and 25% goes through the municipal wastewater treatment plant before discharge. And in 5B, 50% is reused, 50% goes through the municipal wastewater treatment plant before discharge. In B3, 75% goes through the plant and 25% is reused. And then in B4, 50% is reused and 50% goes to the sea. So the methodology we choose is a cost-benefit analysis, and cost-benefit analysis is a fundamental environmental tool for evaluating environmental management strategies, and it enables policymakers and stakeholders to compare the monetary value of cost incurred with the benefit of avoided damage or for improved environmental quality. So the key methodological challenge in cost-benefit analysis of ship gray water is the evaluation of environmental externalities. This doesn't only happen for ship gray water generally, because environmental externalities do not have any market value. Therefore, we use another methodology called shadow pricing to estimate the monetary value of these environmental externalities. And shadow prices are just like P-NEG values, like predicted no effect concentration values that are calculated, and you can use, any researcher can use these values as models in their own research. So we have also the two aspects of the cost benefit analysis is the societal cost and the total environmental benefits. The societal cost is obtained, it is actually the real resources that are used along the wastewater management chain from when it is water is produced, it is used, generated, it is used, gray water generated, treated, and finally discharged. So we got the values of this system, the cost of this system, the cost of treating gray water, the cost of handling gray water at the port and all that. So it makes the societal cost for each scenario. We also calculated the environmental benefit, which we use the shadow prices that we calculated, including other shadow prices we obtained from the literature, multiplied by the mass flows and the removal efficiencies of the treatment systems. We got the environmental benefit due to pollution. Now, the total environmental benefit is the environmental benefit due to pollution and the environmental benefit due to gray water substitution after reuse. So it makes the total environmental benefit. Now, the net social societal benefit is you have to subtract the societal cost from the environmental benefit, and then you get the net societal benefit, which you will see. So we derive a whole lot of cost chain models, which I will not want to discuss here because it will be too long, but an environmental benefit as well cost chain models for these calculations. I will just go straight forward to our results. As explained before, we have the net societal benefit, which is the environmental benefit, total environmental benefit minus the social benefit. Okay, so we obtained shadow prices of contaminants. Some of them we obtained from the literature, and others we calculated. And we realized that zinc and copper have the highest shadow prices, which the negativity of the shadow prices indicates that this represents the marginal societal damage cost of releasing 1 kilogram of this pollutant into the sea. And any scenario that has high removal efficiency of the contaminants with high shadow prices means those scenarios are highly environmentally beneficial. Okay, so for the costs, the societal costs, we have the scenario, which is not surprising, of course. The scenario with the lowest societal cost is scenario 1, which we have explained before. It is direct discharge into the sea. It incurs no cost of treatment, no cost of port handling. Therefore, it makes it a very low cost scenario. However, as we're going to see, it also has no environmental benefit. Okay, but when we go to onboard or the port-based treatment scenarios, which is scenario 2 and scenario 3, we see that the treatment on board and the one at the port increases the societal costs. And then The scenario 4 has the highest societal cost because it has double treatment. You first treat at the port, then you treat at the municipality, which gives it a very high societal cost. So we also look at stakeholder net benefits. The stakeholder costs in the first place is the distributional analysis of who pay among the stakeholders, who pays more in grey water management. And we see that the ship operators consistently incur large financial burden across all the scenarios. The ports also exhibit some moderate financial variation, but it depends on the treatment destination, whether it is reused or it is discharged into the sea. And the port losses are mostly severe in scenario 3 and scenario 4, where the port must pay the municipal wastewater treatment plant for the treatment of the wastewater. So, but small profits also arise in scenario, the reuse scenarios, because grey water that is reused substitutes the cost of purchasing water at the port. Then the total environmental benefit, the value ranges from 0 right up to about 1.2 million under reuse scenarios. So the lowest environmental benefit is obtained from scenario 1, which we already know that there's no treatment, it discharges directly into the sea, so it has no environmental benefit. But surprisingly, we will see another result that it is ranked high, because of its substantial low cost of low societal cost. Okay, but the reuse scenario has the highest environmental benefit, because especially the reuse, 100% reuse, because it substitutes grey water purchased at the port, and no grey water is discharged into the sea. So we see a decrease in grey water, we see a decrease in environmental benefit in scenario 3 among the non-reuse scenario. And this is due to, an increase due to the advanced wastewater treatment plants, and then at the port as well, due to the treatment plant at the port. So for pollutant contribution to environmental pollution, we have the pollutants as already elaborated with the highest shadow prices, which contribute substantially. We have zinc, copper, and we also have nitrogen, and we also have COD, contribute substantially to the environmental pollution. Now, the ranking of the scenarios, we also notice that scenario S1 is ranked the first. It is the least negative scenario. It is the least negative scenario because it has really limited costs, societal costs. It doesn't have cost for treatment. It doesn't have cost for handling at the port and all that. It doesn't incur those costs. So because of that very substantial low cost, it now and a zero environmental cost, then the overall net societal benefit becomes high. It becomes high in economic terms, but with environmental terms, it is not the right scenario. Then we also notice that the reuse scenarios, like the 100% reuse scenario, actually is the most efficient scenario among all the scenarios. And SC4, which has two treatment is the least ranked scenario. And because of this both treatment, it incurs a very high cost, although the double treatment presents a more environmentally friendly, a more efficient treatment and a more environmental benefit. But because of the high cost of the port wastewater treatment plant and the municipal wastewater treatment plant, then it becomes the net benefit becomes really low. Okay, so we try to look at some sensitivity analysis of we look at the effect of the reuse substitution, the substitution of the water for reuse on the net benefits, because we want to know how important reuse is for the net benefit. And then we tested 5 values with the shadow price of water, and then we held all other parameters constant, like the treatment cost, like the pollutant removal benefit and the volume were held constant. And for each value, the reuse benefit terms, I mean the environmental benefit due to reuse, and as well as the net societal benefit were recalculated for all the reuse scenarios. And then we see that under this assumption that fresh water has no economic value and all reuse scenarios perform negatively with regards to net societal benefit. And then in this case, the additional treatment cost of producing reused grey water is not really compensated by the pollutant removal benefits alone. So at the base value of 1.0 multiplied by the shadow price of water, and then the 100% reuse benefits, reuse scenarios perform the best, which also confirms how important reuse is with the overall net societal benefit of grey water management. We also looked at how the water purchase or water purchase at the port could be beneficial in all the reuse scenarios. And we also, calculating, adding the cost by 20% and reducing by 20%. So we noticed that there's not substantial change in the ranking of the scenarios based on the net societal benefit, even though the water purchase cost was increased or it was reduced. There was no net change in the net societal benefit. And this also means that even though in different places in the world where reuse is high, reuse might be high, like in arid regions, there will still be 100% water reuse will still be highly beneficial than the 25% or 50% water reuse. And in this, we want to conclude that grey water treatment alone is not really enough for substantial or sustainable grey water management. Reuse, as we have seen, significantly improved the societal performance, so it is highly encouraged. And partial reuse scenarios where part of the grey water is discharged into the sea and part of the grey water is reused and another portion is treated at municipal wastewater treatment plant before discharge, offers the most favorable trade-off between the environmental benefit and the costs. And then stakeholder incentives are misaligned, as stakeholders, ships pay more than the ports, and the municipality is neutral. It's on the neutral ground because even its cost of treatment, it inflict charges onto the port, and then the port also inflict charges to the ships. So the ship owners pay the most. And also, if we look at the first scenario, we see that it is direct discharge into the sea. So it is only stakeholders that have this environmental stewardship that can be able to look for other reuse, other waste management options, because there is no regulation and there is no obligation to discharge to port retention facilities. So a ship owner which is not environmentally conscious would simply discharge into the sea. Therefore, policies are really required to improve on wastewater, greywater management, especially economic instruments. We already have environmental instruments that look more like MAPOL Annex 4. They look more on sewage, and they neglect greywater. So we have identified these deep structural barriers that exist between all these stakeholders within the waste management, system within Trelleborg. And this can also be applied to other waste management, greywater management systems within, in other regions of the world. And we also noted that treatment and reuse deliver very important environmental benefits that is in alignment with some regulations like the HELCOM BioCC Action Plan, that emphasizes on eutrophication. And then because nitrogen has a very high shadow price, removing nitrogen will be very beneficial. And that will align with some of these regulations. But this also imposes high treatment costs on stakeholders. So stakeholders might want to choose the treatment that would favor their operational costs. Okay. The non-regulation of greywater in MAPOL is one big impediment, as well as previously said. And so there is a need for coordination at the policy level. We also have some few, I don't know if my time is up, but I will just want to speak about a few limitations of the study. We have the data availability. We didn't really have exact data. We see how these systems are very, very complicated. So our data was mostly based on proxies, and because it is a model, then it has to do with estimates. So it is very important that such studies, prior studies, should consider engineering systems in the particular system where the study is being carried out. And then we also have system performance uncertainty. And then if the study did not consider future trends or like greywater, water cost of water trends in the future, and we didn't consider all that. So further studies or subsequent studies will have to consider that. We will have to say that there is a need for coordination among the stakeholders. And for ship operators, first of all, they want to emphasize on the value of delivering to port reception facilities rather than, we want to emphasize on that, delivering to port reception rather than discharging into the sea. And for port authorities also, the establishment of a cost recovery mechanism may also help ports to build like reuse facilities that would improve greywater management, and then increase reuse and improve greywater management. And for regulators and policymakers, the priority should be to integrate greywater management into existing environmental monitoring regimes. That is, to us, it is important. And also, funding channels could be dedicated to assist ports in upgrading their treatment system. First of all, ports that do not have port wastewater treatment plant, and to establish such plants, and for those that already have, to build reuse facilities that could enable the port to instead reuse greywater rather than forwarding to the municipality or discharging into the sea. Okay. So we want to say a big thank you. Thank you to Lighthouse for funding this project. Special thank you to Ida Maya, Eric, and Kent, who are my team partners in the Greywater project in Straumas. And also for the partners, Marine Flock, Greyhab, and IVL. Thank you. Thank you, Headman, Frederick, and Elias, who contributed to this study, as well as the ships that we visited, the ports, and all the municipalities we visited. Thank you very much.
Thank you, Jane, for that presentation. So a quick question, what are your insights or what are the rumors? Is greywater going to be regulated by MARPOL in the future, you think?
The rumors now are that some states have already started to regulate greywater within their areas of sovereignty, like Finland. Finland has started to regulate greywater. I think greywater will be regulated by 2030 in Finland. I believe when Finland begins, there are rumors that other states will follow suit. And if other states follow suit, then it will be an eye-opener for IMO to maybe include it in MARPOL Annex 4, or I don't know whether it's it would be a separate regulation for greywater. But we believe that greywater will be regulated in the future.
Okay.
Yeah.
Great. Thanks. Time is running very quickly, and I will switch to skånska, maybe not Swedish, but skånska. Stort tack till alla presentatörer och stort tack till alla er som har deltagit. Vi har fått 5 stycken presentationer av 5 olika projekt med en sak gemensamt. Alla bär mot en hållbar sjöfart. Och stort tack till Trafikverket för att vi får förtroendet att köra detta branschprogrammet, hållbar sjöfart. Vi kommer att köra fokusgrupp hamnar den 16 december för er som är intresserade av det. Det är med tema på hamnen som säkerhetsnod eller säkerhet i hamnen. Vill ni vara med på det så är det bara att höra av sig till mig eller Elin eller Caroline. Och det ska jag också säga, Elin som har varit med och fixat detta från vår sida, hon slutar hos oss och börjar på hav, för Caroline kommer tillbaka efter sin föräldraledighet. Så vet ni lite grann vad som händer på Lighthouse också. Vi kommer ha vår årskonferens i hållbar sjöfart i mars nästa år. Den fysiska konferensen som vi har varje år, det ser vi fram emot. Men innan dess så ska vi försöka klara av ett sjösäkerhetsseminarium och ett seminarium om CCS också till våren här. Så, stort tack för detta och ha en fantastisk dag.
Tack så mycket. Hej då.
Tack. Hej.
Hej.
Hej då. Hej då.
Dum.